Hey YouTube, it's time for another episode of Fix It Friday. Actually, I think this is the first episode of Fix It Friday, and we're starting off in grand fashion with the repair of a realistic STA-2300. Here's its amplifier module, or one of them. It uses two of these. They're good for 120 watts per channel. And unfortunately, this one's in need of a little bit of repair, which is why it's being talked about. Let's go through the layout here. We've got a snubber cap here, rail filter caps here. This capacitor is apparently part of a passive feedback network. I'm not really sure because I don't have the schematic for the 2300. The schematic over here is unfortunately for the 2100D, which is similar but very slightly different. Anyway, we have a input coupling cap here. You can tell from its orange color, this is a low leakage capacitor. They don't color them orange anymore, unfortunately. You have to rely on type codes to determine whether it's low leakage or not. It was a nice convenient feature back in the day. They don't do anymore. This is a pair of matched PNP transistors. They form the input differential amplifier. You can see where the audio in connects here. Not sure what this little guy is, possibly a current source. These, I'm almost certain, are current sources by their location in the circuit. They're probably a current mirror providing the tail current for that differential amplifier there. Around here you can see the bias circuitry. There's the bias adjustment potentiometer. I'm going to replace that because I don't trust them. The bias transistor is attached via these leads here. These two transistors on heat sinks are the driver stage that drive the power output transistors. These little transistors in here, I'm not real certain what they are. I can presume that they're not drivers because they're too small. I think they're actually part of the protection circuit. I think when there's enough voltage to charge this cap, these start shunting signal to ground and thus prevent overloads. It's a simplistic protection mechanism, but it works quite well. You got an output filter here. Your emitter resistors are here, one per transistor, of course. This amplifier module is having some problems, unfortunately. Keen eyes may have spotted a burn spot on this resistor here. This resistor and this capacitor form a Zobel network. Now the Zobel network is used to suppress oscillation. We want an amplifier that is an amplifier and not an oscillator. These oscillations can really, in addition to sounding terrible, can damage your speakers, so we want to damp them down before they even get started. You'll also note there's a small crack in this capacitor here. I don't know if you can see it, but that's not good. That means it got really hot. There are basically two things that can cause a Zobel network in an amplifier to fail. Either it starts oscillating on its own for some other reason, possibly a bad output transistor or something bad going on in the drive stage, whatever. Or, like many realistic products with mylar or polyester caps, something goes wrong with the cap itself. And I think that's probably what's gone on. These early 80s realistic receivers are actually kind of notorious for mylar cap problems. They have plenty of problems with electrolytics, don't get me wrong, but the mylar ones are trouble too, and that's kind of unusual. What happens with capacitors is these tend to go leaky. And by leakage I mean there is no such thing as an ideal capacitor. A real-world capacitor isn't just a capacitor. It contains what you can think of as a resistor in series, an inductor in series, and a resistor in parallel. It's that resistor in parallel that is known as the leakage path, or the self-discharge path. The higher the leakage, the more self-discharge. Leakage in a Zobel network capacitor is highly undesirable because it causes not only does it screw up the Zobel network, it causes the capacitor to dissipate power, which means it gets hot. Now if it gets too hot, it will actually short out inside and then this resistor will start seeing power. Normally that resistor and that capacitor only conduct significant amounts of current when the frequency is very high. In other words, oscillation frequencies, higher than audio band. But if that capacitor shorts out, this resistor is going to suddenly start seeing normal audio frequencies. That's not good, because this is a 120 watt amplifier, and that's a 3 watt resistor. As you can see, it hasn't fared so well against the 120 watt amplifier. It's burned. So that's not good. I've got to figure out if this thing is oscillating. I've got to figure out why. Or I just simply need to repair the Zobel network. I'm going to replace all these electrolytics anyway. They're quite old. Let's see how old they are. Nishikon uses nice, easy-to-read date codes. 8052, which means the 52nd week of 1980. They're old. They need to get gone. I'm going to replace these Mylars. I've got them in stock. It's a realistic. They're Mylars. They're known for having problems. This isn't the first one I've had with bad Mylar caps. STA, I think 2250 gave me quite a lot of trouble with Mylar caps, but check out that output stage. This is one channel. It's parallel push-pull. Let's see what type of transistors we have on this bad boy. I have a 2SD 287C and a 2SB 539C in parallel. Nice. That's quite a lot of output devices for 120 watts. This has definitely got some beef to it, and I'm willing to bet you, especially into 4 ohms, that it will do quite a bit more than 120 watts. The emitter resistors I checked earlier, I had initially thought they were failing. It turns out my meter leads are bad. And go figure, they're fluke leads. The cheapy Velleman leads gave me the proper resistance, and I checked it with another meter, and indeed they are in specs. These emitter resistors are not the reason this amplifier is burning out Zobel networks. So I've got to dig a little deeper. I'll pull the transistors anyway to redo the heatsink compound on them and redo the mica. I replaced the mica and the heatsink compound in any refurbishment I do. It's just common sense. I'll also replace that variable resistor there, or that potentiometer there, because they do tend to get sulfide on the contacts and either go open or short, and that's really, really bad. It causes the bias to go all squirrely, and that can blow up the amplifier. There's a whole rest of this unit too that I'm also going to be working on, and I'll make a video of that. It's quite a impressive and majestic unit. I hate to see it broken like this, and I'm going to fix it up. Stay tuned.